Assalamu alaikum, dear students. Welcome to the lecture of the classical mechanics. In this lecture, I will discuss the problem number one from the Marion books. The question statement is like that: find the transformation matrix that rotate the axis x3 of a rectangular coordinate system 45 degree toward x1 around the x2 axis. In this, we are given that we have to rotate the x3 axis. When we rotate it by 45 degree, so its position will be changed, and we denoted its new position with x3 prime. And this rotation is toward x1. Toward x1, it means this axis is rotated toward x1. So x1 will be rotated by by 45 degree, and its new position will be x1 prime. So x3 is rotated by by 45, and similarly x1 is rotated by 45 in the forward direction. And this rotation is taking place around the x2 axis. It means x2 is not going to be rotated. x2 and x2 prime, there is no change, there is no rotation in x2 rotation. Okay, so this rotation is taking place about the x2. It means the angle between x3 and x2 will be remain same. The angle between x1 and x2 will be remain same, because rotation is taking place about this axis. So the angle will be remain 90, because we know that x2, x3 and x1 are mutual perpendicular to each other. Now the angle change only between x3 axis and x3 prime axis. Similarly, x1 prime angle change between x1 and x1 prime, and x1 prime and x3, but there is no change of angle between x2 and x1, between x2 and x3. So let's go to solutions. We will just find the transformation matrix. The first, we know that the direction cosine to be given by lambda 1 1, which means the first, this denote for the prime coordinate cos of x1 prime, and this is x1. So x1 prime and x1, so cos of x1 prime and x1, the angle between x1 prime and x1 is equal to 45. We know that our x1 prime axis is rotated by 45. There is no change. Okay, so here we have x1 prime and x1. We will look for the angle between x1 and x1 prime. If we go back, so the angle between x1 and x1 prime is 45. So in this case, we will write 45. So cos 45 is, the 1 over under root or 2, or you can write as under root 2 over 2. Similarly, lambda 1 2, because we have a matrix like this, lambda 1 1. Similarly, lambda 1 2, lambda 1 3, lambda 2 1, lambda 2 2, lambda 2 3, and lambda 3 1, lambda 3 2, and lambda 3 3. And this matrix, we have to obtain this. Lambda 1 1 means this is for prime and this is for unprime. Lambda 1 2 means this is x1 prime and x2. So this, the first indices denote for the prime extent, because x1 prime x2. We know that the angle between x1 prime and x2 is 90, so cos 90 is 0. You can justify this angle from this x1 prime and x2 axis, because the angle between this two axes is not changed. Our rotation is taking place around x2, so there is no change of angle relative to x2 axis. The angle will remain 90. So similarly, lambda 1 3, this is mean angle between x1 prime and x3 So this is 90 plus 45 because something is going to be added. There was for rotation of 45 degree. So cos 90 plus 45, you know that it will become some 100 plus something. So this value of this is this. Lambda 2 1 angle is 90. Similarly lambda 2 2 and lambda 3. We will find all its indices and we'll put in this matrices. So this will gives lambda 3 1, lambda 3 2. Similarly we can find all the entries of this matrix. Lambda 3 3, the angle between x3 prime x and x3, which is 45. This is very good, cos under root 2 over 2. And when we substitute this all entries in the above matrix, it will give us lambda is equal to this matrix. And if we arrange this, if we want to simplify the matrix, we will get lambda is equal to 1 over under 2 0 minus 1 over under 2 0 this and this. So this is our required matrix.